working on part two today, and our part one homework is due tonight, and that third discussion initial post is coming up quick, so don't forget about that guy. Okay, so what are we up to in this module? So in part one, we were essentially trying to look at these 7 columns, which had the answers to the purchase intent for these 7 products on the survey. However, as I mentioned last time, if you want your answers to look like the book, I don't want to be going left and right. We can transpose all this stuff, and we're going to be looking at those 7 rows instead. And doing some basic stuff like averaging and counting, but we want to make sure that we don't count the zeros because that implies someone actually skipped that question. So what we can do is we can set up a little table, just kind of like the book. So this is like the initial first table where we run an average ifs function, um, ignoring the zeros on each of those 7 columns to get the first averages. We can run a count ifs function on those same 7 rows, ignoring the zeros to see how many responses there were. And then, like I mentioned last time, we can sort of just add on all the rest of the stuff they were asking about, because this is going to make our lives easier later if we just sort of keep all of this contained in a single table. So let's take a look at this real quick. What's going on here? So when we are trying to figure out these guys, the distribution of all these answers, all we're really doing is just doing more counting, except we need to divide by the total in order to make it a percentage. So like, for example, let's say I want to figure out what percent of this row 15, what percent of all these numbers are ones? Well, what I need to know is how many ones are in that row and the total number of answers in that row. And then I'm going to say it's 37 out of 140. So that's 2 separate count ifs, and then divide them to get the answer. Then I also added these up just across just to check my work, just to make sure I have 100% of the answers they were asking about. A couple tricks I wanted to point out here is that when you're doing either this section, or if you want to skip this, I like this section though, and go straight here, you can actually drag this right and down if you have like a little section of 1, 2, 3, 4, 5 that you can reference, because that way you're initially counting ones, and as you move to the right, now you're counting twos, and then now you're counting threes. So this whole table is essentially 3 functions. I mean, it looks like a lot of work, but I typed in these 3 functions and then just drug. This is just arithmetic, right? So that was pretty easy. It's just dividing 2 numbers to its left. And then there's some other additional stuff going on over there that I want to talk about in my notes. But I just wanted to start with this sort of the basic idea first. Okay, now, where's this stuff come from? Let's talk about that. So I'm going to move over to my notes for a second and actually go a little bit backwards and start by talking about weighted averages. So I assume everyone figured this out since the part 0 homework was already due, but a quick reminder of how weighted averages work. We need 2 things. We need the data you're averaging, and we need the weights. I like to call the data X's and the weights W's. And then the formula is given by multiplying all your data by its corresponding weights, adding those things up, and dividing by the sum of the weights. So for example, if I was looking at this credit hours homework question, the credit hours are my X's, that's what I'm averaging. The weights would be the frequencies. These tell me how often these particular credit hours occurred. And so I do what I mentioned above. I multiply each pair of X times W. I add up all those products, those pairs of multiplication. I also add up the weights, although the question told you this, so I didn't have to do this, but that tells me there's 100 of those things. And then finally, I divide these guys. And that's how a weighted average works. And a weighted average is really nice because that way I don't have to do 12 plus 12 plus 12 17 times, and then plus 13 plus 13 plus 13 21 times. I can just go straight to the answer by using their weights, which is really nice. Okay, I want to show you a little bit of a shortcut of how to get this answer using a brand new function. So this process here, where we multiply each pair and then add them up, this is called a sum product. And the reason why is because we're summing a bunch of products. Products just means multiplication. So there's a nice function that we can use called sum product, where that allows us to skip this step over here of building a third column, where we just plug in all the x values, comma, here's all my x values, comma, all my weights. And then I can go straight to this 1464 without having to build this thing. So it's nice because it saves a little space. And then I can divide these two things. And if I want to save even more room, I can do all this in the same cell. I can do my sum product first of these two columns and then divided by the sum of the weights. So all you really need to get a weighted average is this guy. I can go straight to the answer using this new function, which is really nice. And I want to show you how I can use that new function today for question 5a. So question 5a is a little bit confusing what it's asking. It's asking you to compute the average purchase probability, where instead of the initial survey responses, initially everyone wrote down 1 through 5 for how likely they were to purchase this. But instead, what if everyone wrote down these answers? So like there's a 25% chance I might buy the product, or a 75% chance I might buy the product. If they did that, then what would their average response be? So how can we do this? Well, we could build the raw data. And what I mean by that is we could take every single one, replace it with a 0. We could take every single 2, replace it with a 25, and write down what all the survey responses would have been if they used these numbers instead. And then it's really easy. I just average all these numbers except zeros, and that would be my average purchase probability, because now I'm averaging purchase probabilities, not 1 through 5s. And so that's what they're asking us to do in this question. What is the average of this set of data? However, I do not want you to build this set of raw data. This is horrible. You can use like a set of ifs or lookups or whatever, and it's okay, but it still takes so much space to actually write all this out. So what we're going to do instead is use a weighted average. And here's why using a weighted average allows us to skip this step, coming up with this new set of raw data. Well, let's say, just like in the workbook, we come up with over here, what percent of these are 1 through 5s? So like I count the ones, there's 5 of them. 5 out of 20 is 25%. So I know 25% of them are ones, so on and so forth. So I do this just like you did for the second question in the workbook, using some counting. Well, that means we actually know the weights of this column, even though, we're pretending we can't see it, because it was a 1-to-1 replacement. So whatever percent of them were ones is going to be the same percent over here that are zeros. And whatever percent of these over here were 3s is going to be the same percent over here that are 50s. So if I know the weights of these guys, I actually know, whoops, the weights over here, because these two things are the exact same, right? It was a 1-to-1 replacement. These two sets of raw data have the exact same distribution if you break it down into pieces. Therefore, if I know the weights of all this stuff, I can use a sum product There's my x's. These are the new things we're averaging. These are the weights. I've already computed the weights in question 2. And there's my average. So all I needed was these 10 numbers, which you already have these in your book. You can just write these down. And I did not have to rely on this raw data. But notice I got the same answer either way. So this is how you should attack this average purchase probability question. Use the fact that you know the weights from question 2. You know the numbers you're averaging because they tell you them in the question. And you can just do a weighted average on these values to get the average that that you would have got if you did this, horrible method. So that's how I would attack questions 5 and 6. It's much easier than doing any other method that I can come up with, at least. You also might have noticed, hey, Jacob, you skipped a step. Where was that division? You're supposed to divide by the sum of the weights. Well, sometimes you can actually skip that step because the sum of the weights in this instance happen to be 100%. And dividing by 100% is like dividing by 1. It doesn't actually do anything. So even better, sometimes you can skip that division. This is one of those cases. It's a cleaner formula here. There was a question in chat. What do we do with the intent 1 table? This is like the raw data. This is just a little example I was making up. So for example, for us, that's the real intent 1. I just made up an example so we could actually see what was happening. So you don't need to build that. That's the raw data. We already have that. One last question I want to talk about because it's a little bit confusing is question 5D. And it says, okay, we got the average in question 1. In question 1, we got the average of all these 1 through 5s. And let's say chocolate bars had the highest average. What they're asking is, in question 5, when we got this new average, will chocolate bars still have the higher average? And I don't know if it's chocolate bars, but that's the idea. And then in question 6, they're asking the same thing. The only difference is in question 6, they're using a different scale. Instead of 0, 25, 50, 75, 100, they're using 0, 2, 10, 25, 50. So in the first case, the answer is yes. But in the second case, the answer is no. And what is the difference? And that's what I want to talk about right now. Why will it remain the higher average up here, but not necessarily down here? Well, the difference is that if we look at these new scales, so like in question 5, the new scale is 0, 25, 50, 75, 100, as opposed to the original scale, 1, 2, 3, 4, 5. Well, in this new scale, notice it's going up by 25 each time. This nice consistency is what is causing the whatever had the highest average before to have the higher average after we switch it to this new scale. On the other hand, in question 6, it goes up by 2, then it goes up by 8, then it goes up by 15. We lose this consistency, and that's why the answer is no in that case. So I've already done the workbook questions for you, but when you get to the homework questions about this concept, this is all you need to focus on. Is the new scale like nice and consistent in that the gaps between each value, is it always the same or not? So that's what I want to talk about, just because you're not going to come up with that on your own. It's a weird little fact that I wanted to point out. So in part 2, we are doing the exact same thing. Like, what's the distribution and what's the average? The difference is we are now taking the average or counting the frequency questions. Like, what is the frequency of which people will buy these products? And so that is just slightly underneath our intent. So now we're analyzing these rows, the frequency rows, but we're doing the exact same thing. And so even though it doesn't really necessarily ask all the same questions, what I would recommend doing is building this exact same table for frequency. And like I said, yes, it looks like a lot of work, but remember, it was really only like 3 functions. And if you're really careful with how you manipulate these values, there's actually an even quicker way to do it instead of redoing these 3 things from scratch. But I'll let you think about it and show you next time if you can't figure that out. So that is the first idea for part 2. And then the second idea is this, essentially ignoring fives. So we're ignoring fives down in this table down here. And the reason why is when people gave a response for 1, 2, 3, 4, it was it correlated to buying the product some amount. 5 was essentially skipping the question. They didn't know, and so it doesn't correspond to an amount that they're going to buy it. And so what we're going to do down below is say, okay, let's ignore the fives, because 5 doesn't mean they're going to buy it a lot. It just meant they don't know. So let's throw those answers out and redo all these steps, only including 1, 2, 3, and 4. And likewise with this one, we're also excluding the fives. And so what you're going to do is build that as a second criteria where you're not just ignoring zeros, but you're also ignoring fives. And so there's 2 ways you can do this. You can either build a brand new table that doesn't have any fives in it, or you can add that criteria to your original table and add some sort of external switch that allows you to go back and forth between part 1 and part 2. Both of those ways work just fine. I can show you both if you want, but that's how you can attack these 2 questions. So it's more of the same, just adding either an additional table or an additional criteria. So that's what we're working on today. So go ahead and get started on that and let me know if you have any questions.